All right, here we go. This is
Yeah, I don't even know number one.
says what
I
is
do know
so it's what is the area of a triangle with sides 14, 25, and 25. So you'd start by drawing a picture here of a triangle. It's got a 25 here, 25 here, and a 14 here. Now,
So 7.
what's nice about this is a area formula for a triangle is 1/2 base times height, right? So we have area equals 1/2 base times height, and we already know the base is 14. So somehow we have to figure out that height. And you're right in saying that when I draw this height in, I'm creating a 7 here and a 7 here, right?
Mm-hmm.
And so here's my right triangle. I've got a hypotenuse of 25. One of the legs is 7. I've got to find the other leg. What I was going to say earlier is this is actually a Pythagorean triple if you recognize it. But say you don't recognize it, it's a triple. What would your setup be here to find the height h of this triangle?
25 squared minus 14 squared.
Right, well 25 squared, let's go ahead and set up. It's 25 squared equals
Oh, yeah.
7 squared plus h squared. And we are going to end up subtracting that 7 squared over to the other side. So 25 squared I happen to know is 625, and 7 squared is 49. And so if I subtract the 49 over, 625 minus 49 is
600, yeah, 625.
no, it's got to be less than that. It should be 500
Oh,
something.
no, sorry. It's 576.
576. You remember it from earlier? And then finally take the square root of each side. So h equals 24.
There we
And
go.
so, you know, it actually was a Pythagorean triple of 7, 24, 25. If you remembered that, it'd be helpful. But we can do it this way, and there's lots of Pythagorean theorem on it. So half of 14 is 7. 7 times 24 will give me 168. So that's my correct answer.
This with my phone.
No, we should use this to study. So it starts off kind of with a multi-step one, but there it is. Pythagorean theorem to find the height, then plug it into the area formula for a triangle. That formula is on your formula sheet,
Also,
even though I told you you should know it, but it's on there.
Okay.
I'm sorry, you should what?
You could also do it like another way, like the Pythagorean theorem and then times it by 2, correct? Or divided by 2. Wait, yeah,
Which actually that's what we did, yeah.
And I like how you guys didn't put the formula, it's just divided by 2, which is fine.
Okay, so it says angle 1 and angle 2 are a linear pair. So I've drawn a linear pair here. In other words, the two angles, 1 and 2, make a line. Now I didn't think too much about which would be which. We should maybe do that now. I'm thinking the x plus 47 is going to be the bigger of the two. So let's call that bigger angle x plus 47, and the little one x minus 9. Yeah. And then what we're going to do is take those two angles. Yes, remember this?
180 degrees.
Yes, so we've got 2x plus 47 minus 9 would be 38 equals 180, and then we solve that for x.
Minus that.
Subtract the 38 over, so that's going to be
Oh, you know what this round, get out of here.
142, and then divide by 2,
Yeah.
71. So now I have to take the 71 and plug it in for x here and here. So 71 plus 47 is 110 plus 8, 118. So angle 2 is 118. I think it's answer choice then. Let's see here, I'll bet. 71 minus 9 must be 62. That's it. All right, number 3. It says a room is to be wallpapered, including the ceiling and floor. So, it's going to be a crazy room, yeah. I don't know why you do that. The room is 18 feet long by 10 feet wide by 7 feet high. So 18 feet long by 10 feet wide. We've got then, let's go 10 and 18, and there's times 2 of them. And that covers the ceiling and the floor, right? So 18 by 10. And then we've also got some the side walls and the front walls. We've got 10 feet wide by 7 feet high. So those are maybe the side walls. So 10 feet long by 7 feet high. And then times 2. And then we also have 2 of them that are 18 feet long and 7 feet high, times 2. Maybe we should put parentheses around these or something. And so when we multiply all of those and then add them up, we'll get our total square footage. Do you remember what the square footage was from earlier?
Yeah. 40. The square
40 square feet.
Yeah. Wait, 40. Yeah. Square feet. Oh, you meant the.
What is it before you divide?
Okay. So 10, 18. Oh crap! I don't know which specific numbers go to 8.
So 18 times 10 is 180. Times 2 would be 360.
Yeah, that's the 361. And then another one's a 252. The other one's 140.
Okay. So this is the 360 here. This is the 140 here. And this is the 252. And if you add all those up,
You did. I didn't write it down. Actually. 252. I got 750.
so we have 752 square feet.
Divided.
And then we're going to take that 752 square feet and divide it by 40.
Yeah.
We get how many?
18. 19. So like,
About 18 point something, and we would round up to 19. What was it? 18.8.
8.
Okay. So yeah, 19 rolls. That's answer choice C.
That was a formula was calculated. This one's right.
That's smart like
I know. It's
that.
not.
All right. So number 4. Here's the idea. We have 2 circles here, an outer circle, and then we have to subtract out the inner circle to leave the shaded ring.
Okay.
So the area. So yes, the area of the circle is pi r squared. So I have pi. Let's call it big R. What's big R here?
A radius.
8. So radius is 8. That's big R, and then pi little r is 5. So I have 64 pi minus 25 pi. And it looks like my answer is in terms of pi. Which one is it?
Oh, geez. Oh, they're all in terms of pi.
Yes.
Hey.
Oh, 60. Maybe 64 minus 25.
A is it. A,
I actually
39
got
pi.
that one right.
Good. You okay on that? Number 5 actually has a quick little trick. I don't know if you remember this, but if you know 2 out of the 3 sides of a triangle, you can find all the other possibilities by add them. Yes, if I can find here, you add them, and then you subtract them to get the other side, and you put the x in between. So it's got to be between 4 and 18, which is answer choice B. And that will cover all the possibilities on that. Number 6 here. Let's go ahead and, is there any questions on any of this?
Are we gonna have to know pi squared by heart, or is that?
No, that's also on the formula sheet. Yeah, just
I know I
not
should
later.
know that.
Yeah, should, but it's on there. So don't spend time memorizing that. Any questions on 1 through 5? We'll look at the next 5 together. Is that good?
Yeah.
Let's move on.
How long are you staying?
I'm staying for a while. We can go through the whole thing if we have time. So what, do you have to catch the bus, or do you
Well,
have
my mom's here.
Oh, is she? I'm planning on staying until she finishes the final, which is she has to 5:30, so
Oh, dang it.
it's up to you.
I wanted to
I
stay.
can see it.
Okay, so number 6. I am recording this too, so you can watch the video. I'll post it on my website.
You're recording it?
Yeah, I'm recording
I see. Can you record one? Can you record this?
it. I can, yeah,
How much?
when I get a chance to.
Okay.
Number 6, it says find measure of angle x if measure of angle y equals 71. So if measure of angle y is 71, then measure of angle z is also 71 because we have an isosceles triangle, as you see by the markings, right? So these are each 71, so I just take 180 minus 142, which is the sum of the two 71-degree angles, and I end up with 38 degrees. Answer choice A. All right, number 7.
So how did you get 71 in both those?
Because see these markings, they point at equal angles. So if I know y is 71, then z also is 71.
Okay.
So that's how I did that. Number 7 says a square has a length of 14. So if we draw our square, length of 14, so that means 14 all the way around. A triangle has a base of 28. So let's draw a triangle here. The base of 28. If the areas are equal, what is the height of the triangle? Well, the area of the square is going to be side length 14 squared, and the area of the triangle we know to be 1/2 the base, which I happen to know, right? 28 times the height. So I end up with a little algebra problem. I just have to solve that for h. So 14 squared is 196. Half of 28 is 14 times h. And if I divide each side by 14, I get my height h. So 196 divided by 14 gives me,
14.
yes, so answer choice 14 is correct. Yeah.
Wait, what one was
Just a minute here. All right, so let's move on to number 8.
Mr. Ram,
Yeah,
are these packets your mom?
yeah, I think they probably are, or by the time you take the final.
In class, but I don't know.
Number 8 says find the value of x. Well, we're going to use a bunch of supplementary angles. You see them here, a bunch of linear pairs.
I'm good at those.
Yeah, so this would be 48 degrees here to make these two add up to 180, and this would have to be 102, right? So then I add 102 and 48 to get 150. Excuse me, and subtract 150 from 180 to get 30. So that's 30 right there, meaning x has to be 150 because it's supplementary with that 30-degree angle. So Mr. Euclid would like to build a fence around his rectangular grass area. His grass area measures 30 by 40 feet. The grass has a path around it that is 5 feet wide. How much fencing material does Mr. Euclid need to enclose the grass area? So to enclose the grass area and the path. Okay. So what he just did is he just added 5 feet to each side. So this is now 40 feet by 50 feet, right? He added 5 feet on each end, top and bottom, and left and right. So he has new dimensions, 50 by 40. And so if we can find the perimeter of that 50 by 40 rectangle, then we've got it. So it's just a matter of adding. Yeah, 180 feet is correct. So 50 plus 50, 40 plus 40, and you got your 180. All right.
Oh, I don't know these.
Number 10, we have triangle ARD is congruent to triangle GRD.
This is side.
That should be a channel, right?
It could be, except there's nothing that says the hypotenuses are congruent. What we can actually say is that by reflexive property, DR is congruent to DR. So now, side angle side.
Wow.
All right, let's see here. This looks like they are similar triangles, and they are. They're actually similar triangles by angle-angle similarity. The vertical angles are congruent, the right angles are congruent. If two angles in one triangle are congruent to two angles in another, they're similar by angle. So I have x in the bigger triangle is to 12 in the bigger triangle as 4 is to 8. And then you have to just solve for x. And then you got it. What does x equal?
6.
Yep, that's it. So answer choice A, 6. Good. So any questions through 11? Good?
I'm good. I'm good.
Okay, here we go. Let's do the next group, 12 through 15. So number 12, it says find x. We've got a right triangle. We've got an angle given. I'm thinking special right triangles or maybe some sine, cosine, or tangent function.
If you have 30 and 90, you start to 60.
Yes. If that's a 30, then that means this is the shortest side. So the hypotenuse would be double the shortest side, which is 8. And this is going to be x, or x is going to be the shortest side, 4, times the square root of 3. So in this case, x would be 4 root 3. I mean, you could expect me to ask any of these side lengths. Actually, I may even give you one triangle and ask for both of these in consecutive problems. 13 says find the area of a square whose perimeter is 12. So if the square has a perimeter of 12, if square means all side lengths are the same. If the perimeter is 12 and there's 4 side lengths, we can take the perimeter 12 and divide by 3. So that means the side length is 4. So if it's 4 by 4, then the area would have to be, I don't see it on here, find the area of a square whose perimeter is, oh, I didn't divide by 4.
3.
Yeah.
Yeah.
Divide right here. Divide by 4 because there's 4 sides, so we get 3. Thank goodness for multiple choice. So 3 by 3 is 9.
I'm doing good so far. And you got the 4 just for the 4 sides.
Yep. Number 14. What's the length of a leg of an isosceles right triangle whose hypotenuse is 100? Wow. So we have a hypotenuse of 100. They told us it's an isosceles right, meaning these two sides here and here are equivalent, right?
Area.
So if we have an isosceles right triangle, then it's also a 45-45 right. So this would be 45 here, this would be 45 up here, meaning that if I'm given the hypotenuse, I can work backwards by dividing by root 2. I don't know if you remember, but with the special right triangles, if you're given the leg of the 45-45 right triangle, you multiply by root 2 to get the hypotenuse. So if I had a leg,
so you're
say,
just going backwards.
yes, you're just going backwards. So if I had a leg of 10 here, the hypotenuse would be 10 root 2. Well, if you're given the hypotenuse is 100, then the leg has to be 100 divided by root 2.
Couldn't you just... Okay, so if you were to find the hypotenuse and a leg, couldn't you just use the Pythagorean theorem and find...
You could. That would be the other way, is label each of these x. So you'd have x squared plus x squared equals 100 squared, right?
Yeah.
And so 2x squared equals a 1 with 1, 2, 3, 4 zeros, also known as 10,000. So x squared would equal half of that, which is 5,000. And so x would equal the square root of 5,000. You could do it that way as well. Same thing here. And here we really don't need to rationalize the denominator. We don't need to multiply by root 2 over root 2. We could just on our calculator divide 100 by root 2, and it will tell us what range we land in for that length. So, you know, when you're not trying to simplify it and leave it in radical form, you really don't have to do this. But I see that I get 50 root 2. Now I know root 2 is about 1.3-ish. So 50 times 1.3, where am I going to land here? Might have to just do it on your calculator. So you could either do the square root of 5,000, or you could do 100 divided by root 2, or you could do 50 times root 2. What do you get?
D.
71.
I got 70.71, which is over 70.
Good.
Yeah.
Answer choice D. All right, so we've got 15. It says find x rounded to the nearest to the 10th here. So I'm given an angle. It's not a special angle, and I'm given a side length, and then a side length I'm trying to find. So what does this tell me I need to use?
Trig.
Yeah,
Sin, cosine.
sine, cosine, or tangent trig. Yeah, not special right triangle trig, but sine,
Use
cosine, tangent.
the sine.
Yes.
What did you say?
So it will
Opposite
be.
hypotenuse.
Let's see, just a minute here.
So,
So we have a sine of 24 equals opposite 8 over hypotenuse x. So what I'm going to want to do then is maybe cross multiply or use the cross product property to swap these two. So I'd have x would go up to sine 24's place, and sine 24th would go down to x's place. And so 8 divided by sine of 24?
Is 19.6.
19.6. So
19.7.
19.7 C. That's through 15. Alright.
Yes.
And that you'll have to memorize. Memorize your SOHCAHTOA acronym to remember sine, cosine, tangent. There's, I would expect at least one of each of those to show up to 3 problems.
Okay.
One
What
of
do you
each
think
of
will be the most problems? Is there like a big deal?
No, we tried to make it pretty even from chapter to chapter, so they're pretty evenly spaced. Probably a couple of them will involve sine, cosine, tangent. A couple of special right triangles and a Pythagorean theorem problem, or an inverse trig. All right, so moving on to 16 through 22 here. It says on 16, once again, we've got a trig problem. Can you tell me the setup on this one?
It's like, okay. Isn't it sine x equals
Well, think about your SOHCAHTOA.
21? Wait, so
Which one involves
4 over 21 because
the cosine.
cosine? So you have cosine of x degrees equals adjacent 4 over hypotenuse 21. So this is one in which you have to use your inverse trig to find the angle. Anytime you're trying to find the angle, it's inverse trig.
so is 4 divided by 21.
4 divided by 21, and then hit second cosine, and it will take inverse cosine of that, and it will give you your angle measurement in degrees.
Equals?
Uh-huh.
Second.
It says syntax error.
Well, okay, you got to go 4. On that one, I think you got to do second cosine first,
Second cosine
and then do 4 over 21.
4 divided by 21.
Yep, 4 divided by 21. Make sure you're in degree mode, and hit enter, and it will give you the degree measurement. So 79 degrees.
So to hit shift, it goes into second, but it's the cosine to the power -1.
That's what you want. So hit shift,
Okay.
and then cosine, and then in parentheses do the 4 divided by 21. 79 degrees.
Okay.
All right, now we're moving out of trig back into triangle congruence, I think here.
Okay.
So what I like to do with these is kind of mark these up, or at least mentally mark them. So we have AC is congruent to CY. Angle A is congruent to angle Y, and then
Angle side angle.
it will be because the vertical angles are also congruent. So that's an angle side angle pattern.
Yeah. What's the area of what? What's a rhombus? Okay.
Well, with a rhombus looks like this.
Oh.
All 4
yeah.
sides are equal. You've got this long diagonal of 34 and a shorter diagonal of 20. So long diagonal of 34, shorter diagonal of 20. The area formula for a rhombus, when you're given the diagonals, is 1/2 diagonal 1, 20, times diagonal 2, 34. Half of 20 is 10. 10 times 34 is 340. So it's 1/2 diagonal 1 times diagonal 2. Diagonal 1, diagonal 2. So if you're given the diagonals of a rhombus, you multiply them together and divide by 2, and you got it. The other way to do this would be to think of this as 4 right triangles. There are actually 4 congruent right triangles here. So you'd find the area of one of them and then multiply them by 4. If you don't remember the formula. All right, number 19. This is recent. This 42 right here. Yeah, well, it's not the same thing because it's not a central angle. This is an inscribed angle. It's down in here. So the arc is half. Or I'm sorry, the arc is double of the angle. The angle is half the intercepted arc. Although we don't need that here. So all this is saying is that both of these angles intercept the same 84-degree angle arc, so they are congruent. So if this is 42, then this also has to be 42. Yeah.
I'm confused on how you found this, but I get how you got 84.
What's that?
I get how you got the 84, but
You don't actually need the 84 in here. It's good to know that the intercepted arc is always double the inscribed angle, but you have to just look at my coloring scheme here. Both arcs intercept, or both angles, this angle right here intercepts that arc, and this angle right here intercepts the same arc, so they must be congruent angles.
I see. Okay.
All right, 20. What is the area of a regular hexagon with a radius of 8? So if I draw my hexagon, it looks like this. 1, 2, 3, 4, 5, 6. And then I draw in the radius of 8. If you just look at one triangle of the hexagon is made up of 6 equilateral triangles. If the radius is 8, then that means the base of the equilateral triangle is also 8. Because a hexagon is made up of 6 equilateral triangles. Equilateral triangles are equal sides. They all are equal sides. So if you just take and blow up one of these equilateral triangles, here's my base of 8. Here's my idea. I'm going to find the area of one of these and multiply it by 6. So if my base is 8, in an equilateral triangle, when you draw in the height, you split it into a 30, 60, 90 triangle. It's a special right triangle. Meaning this right here is 4, so is this over here, and the height is going to be 4 times root 3 every time. It's going to be the base divided by 2 times root 3 every time for an equilateral triangle.
Wait, but would it be 8, 8, and 8 because they're all equilateral?
They are,
You just
yes.
use the height, the Pythagorean theorem to find it?
You could, but that's overkill. If you know that this is a 30, 60 right triangle, you know that the height is always going to be half the base times root 3 every time. If I had told you the radius was 6, then the height would be 3 root 3. If I told you the radius was 9, then the height would be half of 9, 4.5 times root 3 every time. And that's because an equilateral triangle, when you split it in half, is a 30, 60 right triangle. And in a 30, 60 right triangle, the side opposite the 60-degree angle right here is always the shortest side times root 3.
But you didn't take it as the base.
Okay, because this is an equilateral triangle, if the radius of this hexagon is 8, then all the way around we have 8s, including the base. So the area of one triangle then, let's go over here and work this out. Area of one triangle will be 1/2 the base 8 times, base is 8. I'm going to take the whole thing, times the height 4 root 3. So half of 8 is 4. 4 times 4 root 3 gives me 16 root 3, but that's only the area of one hexagon. Now I have to take the 16 root 3 and multiply it by 6. So my total area, the area of my hexagon, let's draw a little hexagon here, is equal to 6 times the area of one of the triangle. So 6 times 16 root 3 gives me 96 root 3, that's right. Alright, so there's through 20. Are we okay on that?
Yeah.
Right, let's go and look at the next slide here. 21 through 25. So 21, it says point A has coordinates -2, 4. I'm going to draw a quick sketch here. -2 over 4 up. So there it is. Here's A. And it says it's reflected about the x-axis. Now the x-axis is this one right here. If I reflect it about the x-axis, it's going to put it the same distance down below that it was up above. So it's going to land A prime down here. So A prime is at -2, -4. Just think about, too, as you prepare for the final, what would happen if I were to reflect this over the y-axis up here? Yeah. And the y-coordinate would stay the same. Yeah, so it's good to think about that because that's how I could change the problem up, right, from a review to a final. Reflecting over x versus reflecting over y. So make sure you know your difference between your two axes, x and y. Go from there. All right, 22. This is a little more recent. Find the volume of a cylinder. We know volume of a cylinder is base times height. Okay, that formula will be given to you. It's on the sheet. With a diameter of 6 and a length of 16. So the cylinder has a diameter of 6. Okay. The cylinder, if I draw it here.
You know how you leave things in the terms of pi? That always confuses me. Yeah.
It saves a step, though. It's kind of nice to leave it in terms of pi. So I have pi times radius squared times the height. The height is actually the length of the pipe, 16. It's as if this pipe were laying on its side. And then the diameter, of course, is 6, which makes the radius equal to 3. Okay, so radius is 3, the height or length is 16, and there's my volume. Pi times 3 squared, so I've got 9 pi times 16 equals 144 pi cubic inches, which is answer choice C. 23, it says in a right triangle, the two acute angles are always, well, if in the right triangle you take away the 90, what are you left with?
Wait, sorry.
Right.
I'm like,
In a right triangle, here's my right triangle.
always
There's a 90, I got to pull that out. What's left?
acute.
Cute. Well, a line?
Wait, in the
No.
right triangle, two acute angles.
So
always-
in a right triangle, there's my right angle, so I know it's a right triangle.
Oh,
The
two
two,
angles are always complementary.
yes, because they have to add up to 90.
And if you already have the 90s, 90 equals
Yes, that's right. 24, find the area of the small sector. So area of the small sector is going to be pi times 7 squared. That's the area of the whole circle, right?
Yes. That's
Now-
that, and then you minus the area of that.
Well, we can just multiply by the fraction that's represented here. We have 43/60ths of a circle.
Ooh,
43/60.
Mr.
yeah.
Angelo.
So 43/60ths of the area of the entire circle. So 40. It's helpful if we can simplify this, although we're allowed to use a calculator, so it's not a big deal. But we could lop off the zeros. 4 over 36 is 1/9 times 49 pi. I still probably need some calculator help on that. But 49 pi divided by 9. Might be able to do it there. So 150 divided by 9.
153. 53.86
Divided by 9.
divided is 117.0.
17?
Yeah.
Okay. So we'd say it's between
15 and
15 and 20. All right. Another volume one here. What is the volume of a cone with a radius of 7 and a slant height of 25?
That's the area of the base times the slant height.
Which would be 7.
Well, don't forget your 1/3. It's 1/3, and this will be on your formula sheet. 1/3 area of the base, which is pi times 7 squared, times the height. Oh, wait, what is the volume of the cone with radius? Oh, let's draw a picture here. We got a cone with a radius of 7. So there's my 7 right there. And we've got a slant height of 25, but I really need the actual height of the cone in there.
Oh,
So
no, but it's just a slant height.
the slant height is
Oh.
25, so I can't put that in right here. I need the actual height. Do you recognize this triple from earlier? It
Yes.
goes with 7 and 25.
24.
No, I don't.
24 goes to 25.
What,
seven.
what would you do if you didn't recognize that, like Sam
It
did?
was the very first time.
What would you have to do if you didn't recognize the triple? Yeah, you'd have to do Pythagorean theorem to find it. So if you take that 1/3 of 49 pi times 24, why don't you go ahead and calculate that rounded here. Let me pause this.
51.
Wait, no, I got. No, it's not. It's 1,200.
49 times pi divided by 3
Don't forget times 24.
times 20. Okay.
I need 49 times 5, which is 150.
1230.88.
So 1231 answer choice C is it. Okay. 5. All right. Ready for the next 5?
Yeah.
Okay.
What time is it?
Bring it on.
30? Oh.
All right. 26 through, you get through 31 here, next 6. So 26, find the surface area. Well, surface area, this is a triangular prism, and this formula will be on your sheet. It's going to be 2 times the base plus the perimeter times height. When
Okay.
we say base, we don't mean the 6 on here. That's a lot of, yes, a lot of students think that. What's the area of the space? Let's calculate.
160
120
times 2,
That's
which would be 120.
plus perimeter?
No, the base
What?
isn't the rectangle.
No.
The base
Oh.
is the shape that is matching here and here.
So it's,
Dang it.
It's
Well,
1/2.
48 divided by
Times
2.
2.
48 divided by 2 is. No.
Yeah, times 2b. 2
I know, but he's right. The area of the base is 24. You are going to then multiply it by 2. So 2 times 24 plus, look at this, 6, 8. What goes with 6, 8? The triple?
Oh, shit.
It's 10.
Yes. So we have a perimeter of 18 plus 6, or 24, and a height of, here's my height right here. It's actually the
Wait.
depth of it.
Oh, wait.
Oh, you're right.
Perimeter is the 6, 8, and the 10.
10.
The height is the 10, which is actually the depth.
So 240 plus 48.
So 48 plus 240, which is 288.
I did that in my head.
All right, number 27.
I'm a genius.
This distance formula will be given to you on the sheet. But the distance is just, you can actually do this in your head too. What's the distance between the x coordinates here?
4.
Yeah, so you have 4 squared.
And then
Show me the.
What's the distance here? Distance of y coordinates.
crap.
7.
7, yeah.
4 squared. I didn't know this.
So
distance.
16.
Plus
16 plus 49 is 65, so square root of 65, answer choice C.
It's not. Wait, I got this. Wait, oh, never mind. I thought you were actually.
What about the divided by 2 and stuff like that?
So divided by 2, that's that's the midpoint stuff.
Oh, okay.
So 28, it says the midpoint of a segment is at -2, 5. So draw a quick sketch here. We got the midpoint is at -2.
1, 2, 1, 2, 3, 4, 5.
I'm gonna run out of room here. -2, 5. Then we have the other endpoint at 3, comma, way up here at 12. Let me erase this.
Midpoint. That's weird.
So this is 3, 4, 5. Let's keep going on up here. 6,
-12.
7, 8, 9, 10, 11, 12. So 3, 12. So here's one endpoint. Let's call that B. Here's the midpoint. Let's call that M. What's the other endpoint, A? It's going to be way down over here.
Yeah.
Maybe right around in the middle of this triangle over here. But
Negative.
A. So here's how you can do this. If you understand the idea of midpoint, you don't need a formula. You could do this algebraically with a formula, but we're in geometry, right? Let's use our geometric.
Function.
Yeah, just kind of look at the picture here. This is more of a geometric way, a visual way of doing it. So to go from -2 over to 3, I've got to go how many units right?
5.
And then I have to go how many units up to go from 5 to 12?
7.
Okay, keep that in mind. That means I have to go, instead of going 5 right, I'm going to go 1, 2, 3, 4, 5 left. And instead of going 7 up, I'm going to go
7 down.
Yeah, so I'm at negative 2, 5, so I'm going to go all the way down to here. So let's move our point. So it is negative 7, 2, yes, negative 2. That's it. So no formula necessary, just a graphing grid, and knowing that if this is the midpoint, you got to go over and up, you got to go the same down and left, right? That's it. All right, 29, the perimeter of the triangle is shown. Okay. Couple ways you could approach this. This is a right angle. These are both labeled in terms of x. So you could use Pythagorean theorem to find x if you'd like to. But think about this for a moment. If the hypotenuse is 20, and that's the longest side, right? What's the most that x could be if these are in a 2-to-1 ratio?
10.
10 is the most it could be. That's
Yeah.
the most it could be. It actually ends up being 9 if you do the Pythagorean theorem. This is 18. But the most this could be is 10. It actually couldn't be 10. But, you know, if this was 10 and this was 20, we'd be at about 50. So it's got to be less than 50 using a little bit of reasoning. All right, got a little bit of algebra snuck in here. So solve the quadratic equation, x squared minus x minus 12. Looking at these solutions tells me it can be factored. No quadratic formula necessary. So we're looking for factors of negative 12
But that equals 0.
that add to equal negative 1, actually, and then set it equal to 0.
So there's 3, 4.
Yep, so x minus 4 and x plus 3. Now, if those are the factors, then what are the solutions according to the zero product property?
Negative 4. No, negative 3 and positive 4.
Yes, exact opposite. So by the zero product property, we set each factor equal to 0. Solve for x, you get positive 4 and negative 3, which is answer choice B. 31. You could do this by elimination. You could take the second equation right here,
Yeah.
multiply it through by 2 on both sides, creating the equation 4x minus 6y equals 8. And then right below it, 3x plus 6y equals 6, and then solve it. 7x equals 14, so what does x equal?
Wait,
I mean, there's a couple ways to go about this. You could also work backwards and just start plugging numbers in, x's and y's, and seeing which one works for both equations. That would work too. Although the elimination on this is pretty easy. I get x equals 2. That limits it down to either a or b. So if x equals 2, I know that if I plug 2 in for x in the top equation, looks like I'm going to get 6y equals 0, so y equals 0. So the 2, 0 one is the one that works. You could see it here. I might need to erase this to see it, but do you understand the idea of it's either elimination or substitution?
Wait, could I do substitution?
You could, but if you were to do substitution, you'd have to solve for either x or y. And when there's
But when I solve for x, I got negative 7x equals 3.
that's ugly.
Yeah.
If that's even
I don't
correct.
know how to do it.
It may not be correct, but
okay.
the elimination, the idea is that you want to multiply through one or both of the equations by some number that when you add the equations,
So they equal?
yes, but are opposite signs, so that when you add the equations together,
Oh, so one of the signs are equal. So, but they have to be like, so, yeah. Okay, I got it.
yeah, so then when you add them, it
Yeah.
cancels
then-
out.
Negative 2y becomes negative 6y.
That's elimination. But like I said, you could have just started plugging in numbers, like plug in 2 for x here and 0 for y. 3 times 2 is 6 plus 6 times 0 is 0 equals 6. It works in that one. Does it work in the second one? 2 times 2 is 4 minus 3 times 0 is 0 equals 4. So that one works.
One thing I forgot on how to do is I understand how to do this one, but if the 2x and 4, let's say, are swapped, how would you then do it?
Here?
If it was if 4 minus 3y equals 2x.
Yeah, then you'd have to use substitution. So if you had something like 2x equals 4 plus 3y, something like that, you either have to move this over to make it look like what we just had, or solve this for x and then plug it in up here using substitution.
Can you show me how you move it over? I forgot how to
Uh-huh. Well, the moving over is just subtracting 3y from each side. The tricky part is that 2x and 3y are not like terms, so you can't actually combine them together. So we would just rewrite it as 2x minus 3y equals 4, and then we're back to where we started.
Okay.
So it's just going to end up moving over being the opposite sign.
Thank you, Mr. Rowe.
No problem.
Thanks.
Yep. So do you want to keep going, Andrew, or
Yeah, I can stick down.
I might as well finish the video and then I'll have it for next year too. So 32, we've got, given that the two shapes are similar, solve for x. So we're told they're similar. When I see that word similar in triangles, I'm thinking proportion. So you see how to set it up here? Let's see. The 16.2 goes with the 20, right?
Yeah.
Equals the 21.5 goes with the x, and then we cross multiply and then divide. You go cross multiply and divide and solve for x. So we got whatever 20 times 21.5 is.
430.
430.
Yeah.
And then divide 430 by 16.2 and you'll have your x.
27.
27. Okay. So B must be then. So 430 divided by 16.2.
Hold on. So what?
430 divided by 16.2.
Yeah, that's 27.
Okay. So this one, this one. All right, 33. If we assign letters A, B, and C to the quadratic, 3x squared minus 2 equals negative 4x, the value of A plus B plus C is okay. This is just testing to see if you know how to identify A, B, and C. And before I can identify A, B, and C, I have to add the 4x over. Set it equals 0. So my A is the 3, my B is the 4, and my C is the negative 2. And if I add those two up, 3 plus 4 minus 2, I get 5, which is answer choice C. All right, so 34. Which equation could be used to solve for x? So here I am at the 41-degree angle. The x here would be the adjacent side, and the 22 would be the hypotenuse. So I need the one between SO, CA, and TOA that involve A adjacent and H hypotenuse, which happens to be cosine. So it's got to be one of my cosine ones. Oh, I only have one cosine one up there. So it's cosine 41 degrees equals adjacent x over hypotenuse 22, and that's it.
Okay.
35, this is a recent one. There's a theorem that says the product of these two parts, 3 times 5, equals the product of these two parts, x times x plus 4. And that comes from the 3, it's not 3.5, but 3 times 5.
Oh, 3 times. Okay.
That comes from making these into triangles. They're actually similar triangles. It can be proved that they're similar by angle. And we set up proportions. So it's kind of like, 3 is to x as, 3 is to x as x plus 4 is to 5. So 3 is to x as x plus 4 is to 5, and when you cross multiply, you end up with this equation. That's how you prove this theorem. But the theorem says that these two parts, 3 and the 5, when multiplied together, equal these two parts, the x and the x plus 4. So I have 15 equals x squared plus 4x. And once again, I have a quadratic equation, kind of like up here at 33. So I'm going to subtract the 15 over. I have x squared plus 4x minus 15. And that is not factorable. You can kind of tell from the answers. There aren't any rational numbers for the answers. So I've got to use a quadratic formula on this, which says that x equals the opposite of b, so negative 4 plus or minus square root of b squared. So the 4 squared would be 16 minus 4 times a is 1 and c is negative 15, all divided by 2 times 1. And then we got to see which one of those over there matches up with this. I got a negative 4. Might miss a sign in here somewhere? Negative 4. Oh, it could be the none of these. That's why. I think it does fall into the none of these category. It's negative 4 plus or minus. This ends up being 16 times. This is positive 60. 16 times 60 is 76. So I have negative 4 plus or minus square root of 76 over 2. Oh, it could be one of those because it could be simplified. So we need to keep going. So it's x equals negative 4 plus or minus square root of 76 over 2. This is one of the tougher problems in here, algebraically speaking. I'm thinking it is probably going to be answer choice C. Here's why. The 76, if you do a factor tree on it, will factor as 2 goes into that 38 times, right?
Yeah.
38 would be 2 and 19. And so that's going to factor as 2 times the square root of 19. So this negative 4 plus or minus square root of 76 over 2 becomes negative 4. Let's write it over here. We'll run out of room on this one. So if x equals negative 4 plus or minus 2 root 19 over 2. And I notice that there's an even number on each of those terms, right? So I can take out a 2 from the top. So if I factor out a 2, I'm left with negative 2 plus or minus square root of 19 over 2. If I factor a 2 out from the top. And then I can cancel the 2's, leaving me with answer choice C. So here's this one right here. That's a tricky one. Number 35. Probably you won't be asked one that you'll have to use a quadratic formula, but you should know that the product of these two equals the product of these two. I think if there's one on there, it won't be a quadratic, but it could be if it's on the review. You never know, but that's worst case scenario. Number 36, equation of a circle. I don't know if you remember these from the most recent test, but equation of a circle goes like this. If the center is 3, negative 4, then we're going to have an x minus 3 squared and a y plus 4 squared. And if the radius is 4, then it will equal 16, radius squared. So we've got to have an x minus 3 and a y plus 4 squared equals the radius squared 16. Yep. That's a choice. Let's look at the next step over here. All right, 37 through 39. So 37, the figure above the figure to the side here. Let's see what we got. All right. Angles 1 and 2 are what type of angles is what we're asking. It looks like they are alternate for sure.
Yeah.
Exterior, they're on the outside, yeah? Answer choice A. 38, same picture. What are 1 and 3? Do you recognize those?
Yeah, 1, 2. What are alternate and 3?
Well, they are. Well, they don't alternate. The alternate, they'd have to be on opposite sides of the transversal.
Okay.
Interior, they'd have to both be on the inside
It
between.
would be the corresponding.
They are corresponding. They're in the same position. That's right. All right. Uh, 39. Here, let's erase that. So 39, it says find x. Well, let's see. 72x. Is there something missing here?
Oh yeah, I know.
An 80 up here?
Yeah.
Huh, I don't know why it didn't come through here. I don't know what happened. So that's an 80?
Yeah, and then on the bottom left, it's in parentheses 3x plus 5.
Okay. All right. Now I have enough information. So these 4 angles should add up to 360 because it's a quadrilateral.
Okay, so how do we get onto that?
So we do 80 plus 70.
Okay.
So it's going to look like this. Different color here.
And then those added up equals 150.
Plus, yeah, is 150 plus 2x plus 3x plus 5 has to equal 360. And then we combine like terms, so you're right. That's 150 plus 5 is 155 plus 5x equals 360. And then 5x equals 360 minus 155 is 360 minus 155. What is that?
205.
205, and then divide 205 by 5.
41.
Yeah, so answer choice A. All right, 40, it says, what is the slope of the line perpendicular to this line? So first I would solve this for y by subtracting the 2x over. So y equals negative 2x plus 12. So the slope of the line perpendicular to that one is going to be opposite reciprocal of this one. So opposite reciprocal of negative 2 would be positive 1/2. Reciprocal of 2 over 1 would be 1 over 2, and the sign should be different.
Okay.
That goes way back. 41, let's see, the equation of the line passing through 1, 3 and negative 1, 7 is, well, we should probably start by finding the slope. And we find the slope by subtracting the y's, putting those on the top of the fraction, and then subtracting the x's and putting that on the bottom of the fraction. So 7 minus 3 is 4 over negative 2, which is negative 2. So it looks like I only have one up here with the negative 2 slope. You see it?
Yeah.
Answer choice B, isn't it? 42, let's see. This is on the most recent test. We've got a little theorem that says the outer segment, 10, times the whole thing, which would actually be 35, 10 plus 25, equals the outer segment of the other secant line, x, times the whole thing, which they are telling us is 40. So it's outer times whole thing equals outer times whole thing. They meet at the point. So I've got 350 equals 40x, and when I divide 350 by 40, I get
350 divided by 40.
Yeah.
9.
9-ish, okay. D, answer choice D. All right, 43, it says find the measure of an interior angle of a regular octagon. Okay. Measure of an interior angle of a regular octagon. So it's a matter of plugging it into our formula. We have n minus 2 times 180. That's the sum of all the angles, and then you got to divide by the number of sides, 8, to get an individual angle. And all I have to do here is, I should say n on there. That's the general formula. It's n minus 2 times 180 divided by n. So we just need to plug 8 in for n. So if I changed up the number of sides, it'd be the same formula. This is the formula that we got by figuring out how many triangles can you break an octagon into. You can break it into 6. And each triangle has 180 degrees as the sum of its interior angles. So 6 times 180 would be the sum of all the inside angles. But then you got to divide by 8, because there are 8 angles all equal to each other going around the octagon. So that's where this comes from. So 6 times 180, 6 times that one would be 640, that would be 1080 divided by 8 when we plug in 8 for n. And it goes in 1 time 28, 3 times 40, 135, 135 degrees. Wrap this up here. So 43 through 45. This is did 43, 44 maybe through 44 through 47. So determine if the two triangles are similar. So what theorem justifies this? Well, it looks like it could be a side angle side thing from here. The question is are these proportions the same?
That's when you do like the 6 over 4.
Yes. Does that equal 8 over 12? And it sure does. 4 6 reduces to 2/3, and 8 12 reduces to 2/3. So you might have to reduce them to see if they're equal. The other thing you can do is cross multiply. So if you cross multiply and you get the same number, which we do, they're both 48, then they have to be similar, and they're similar by side angle side. 45, the triangles are congruent. Oh, okay. Looks like they share a side here, right? So they're going to be congruent by side, side, side. I see 3 congruent side markings in there. And 46, the tangent of angle A is, let's see, angle A is right here. Here's angle A. So tangent of A is going to be equal to the opposite 10 over the adjacent 20, which reduces to 1/2. That's just testing your definition that tangent, TOA, is opposite over adjacent.
Okay.
All right, 47. Find the missing sides and angles of triangle ABC. If angle A is 30 and angle C is 90. Okay, so we have the 30, 60. So this is 30 over here. Let's call that angle A. Angle C is 90, so we'll call that C. And then B up here would have to be a 60, right? 30, 60, 90. If we have a 30 and a 90, that's 120. 180 minus 120 is 60. So I have a 30, 60, 90. It says CB is 11. So that would mean the hypotenuse is double that at 22, and the CA would have to be 11√3, according to our special right triangles. So looks like these are written in decimal form. Missing sides. So it's got to be either B or D. Angle B is 60 degrees. Side C, what they're referring to here is side C is going to be opposite angle C. So 22, and then B is 19.1. 11 times √3 must be 19.1. So I think we've got it. Answer choice B on that one. All right, so 47 we did, 48, a little proof here. This is given AD is parallel to EC, so they're parallel. I use these little arrow markings here. BD is congruent to BC, so BD is congruent to BC. Prove the triangles are congruent. So angle D is congruent to angle C. Okay, so we're going to fill in the blanks here, huh? Looks like they got ABD congruent to EBC by vertical angles. Eventually we want to do angle side angles, so they're basing it on the fact that these are two parallel lines. So if you have parallel lines cut by a transversal, then the alternate interior angles, D and C, are congruent. So it must be answer choice C is the fill-in. It's D and C are alternate interior angles, and that's what you would need to prove the triangles are congruent by angle side angle. Fill in the blank. 49, C, find the values of x and y. Well, we know that vertical angles are congruent, so 3x plus 2 would have to equal 110. So 3x would equal 108, and x would equal, it goes into 10 3 times and 18 6 times. So x equals 36. So there's our x. We got two choices here, though, unfortunately. We also know that 5y plus 110 would have to equal 180, right? Because they are supplementary. So 5y plus 110 equals 180. So 5y would equal, if you subtract the 110 over, you get 70. So y equals, goes once into 7, and 4 times into 20, so y equals 14. Answer choice B. All right, 50, it says, which two lines are parallel? So you have 3x minus 2y. So we have to check slopes on each of these. If I take this one right here and solve it for y, I have negative 2y equals negative 3x plus 10. I'm subtracting the 3x over to the other side. And then if I divide each side by negative 2, I have y equals positive 3 over 2x minus 5. So my slope for this one is 3 over 2. And I get that by solving that equation for y. So now I have to do the same thing for 2 and 3. You'll see here if I divide by 2 on each side, I have y equals 3 over 2 plus 6 divided by 2 would be 3. So once again, 3 over 2x, I should say. I have another 3 over 2. That's the number 2. So 1 and 2 are at least parallel. What happens in 3 is when I divide each side by 3, I get y equals 2/3 x plus 4. Well, 2/3 is not exactly the same as 3/2. So it's only lines 1 and 2 that are actually parallel. Gotta solve each equation for y, do the algebra, and then compare the number in front of the x, which is your slope. If the slopes are the same, the lines are parallel.
Okay.
Was the precise name for the quadrilateral ABCD with vertices? Okay, we might have to draw the graph for this. We have to draw it pretty accurately at 2, 4. 2, 4, that's my A. B is at -1, -1, there's my B. And C is at -6, 2, 3, 4, 5, 6, -6, 1. So that's C. And then -3, 5 would be, 3, 5 is up here. That's D. So if I connect those, you know, my picture doesn't look like it's any of those, but let's see. It says, what is the precise name for the quadrilateral? So I'd have to decide, first of all, if those 4 sides are all the same length. So I've got to do a lot of work on this. Could probably check with diagonals as well, but just checking to see, let's see here. If these side lengths are the same. So from 2, 4 to -1, I say -1, yeah. So from A to B at 2, 4, we're going 3 over and 3 down. So 3 squared plus 3 squared, and we take the square root of that to get the distance. So 9 and 9 is square root of 18. So the distance from A to B is root 18. And I have to do that as I work my way all the way around. I've got to find the distance from B to C. So from -1 to -6 would be a distance of 5 units. From -1 to -6 is 5 units. So I have square root of 5 squared plus, and then from -1 to 1 would be 2 units. So 25 plus 4 is square root of 29. So it's not going to be a rhombus. It still could be any of the other 3. Let's see what our distance from C to D is. So from -6 to -3 would be a distance of 3 squared, plus 1 to 5 is a distance of 4 squared. Wow. So 3 squared, 4 squared is going to be 9 plus 16, or 25, which is square root of 25 actually equals a whole number 5. So I've got a 5 here, a square root of 29 here, a square root of 18 there. I think I could stop and say it's just a regular run-of-the-mill quadrilateral if I've done all my calculations right. Because I have 3 sides that are completely different. To be a rhombus, all 4 sides would have to be equal. To be a rectangle, the opposite sides would have to be equal. Same thing for a parallelogram, but for a rectangle, you have to have right angles. And I don't think I'm going to get right angles out of that. So assuming I did all my calculations correct, that's just a quadrilateral. 52, it says, what is the missing reason here? Anytime you prove triangles are congruent, and then you prove their parts are congruent after that, it's going to be CP-CTC. So it's like, triangle, you remember that? Triangle is congruent, and then it says, now prove angles and sides are congruent. It's CP-CTC every time. 53, it says, suppose you measure your height to be 6 feet. So here's me at 6. And the length of your shadow is 4 feet, so not quite as long as my height. And then we have a tree that's casting a shadow of 10 feet, and we want to find the height of the tree, h. Does that look familiar?
Yeah.
So we've got a little bit of proportional reasoning here. So 6 is to 4 as h is to 10, and we cross multiply. 60 equals 4h, so h equals 15 units, 15 feet. All right, 54, the vertices of a triangle are 1, 2, 3, 4, and 5, 0. Translation maps A to the point -1, -1. Find the translation rule in the image of C. Okay, so translation rule is going to be just how far am I moving from A to this point. So from 1, I move 2 units left to get to -1, right?
Yeah, 'cause you gotta go back to it.
Yes.
Yeah.
And so it's going to be T -2, comma. From 2 to -1, I'm actually moving 3 units down. Can you picture that? So from +2 down to -1, I'm moving 3 units down.
Okay.
So it's T, and then of triangle ABC. So there's my translation. There's probably more than one of those here. Yep, there's 2 of them. So the question is, what does this do to point C? Here's point C at 5, 0. So if I'm going to take point C and move it 2 units left, my new point C, call it C prime, would be 3, because 5 minus 2 is 3. And then 0 minus 3 is -3. So do I have a 3, -3 in there? Answer choice A. That's the translation. Then the last one here, 55, it says find the rotation of 60 degrees about the origin of AB. So if this is a hexagon, each one of these is 60 degrees down here. So if I take AB, which is right here, and I move it 60 degrees, we're going to go in a counterclockwise direction, so I'm going to land right at AF, which is answer choice B.